Hello, everyone, and thanks for joining me again today for another session of me working on drakon renderer. Let's switch to the code view. During the last session, I prepared some of the groundwork for giving our new valent points unique names. Today, I'm hoping to finish it. So I hope you have a nice cup of coffee or tea, and let's write some code together. So first of all, let's see how this would react to an arbitrary next available point name. It's only used here. Let's call it 3. Very adventurous. Oh, this cannot be a string. Primitive diagram 1. But primitive diagram 1, if I remember correctly, does not have any valent points. So let's switch to simple diagram 3. So I hope everyone is having a nice day. It's a certainly nice sunny winter day here where I live. Okay, let's try to run this now. Three. That is good. Perfect. And let's start with 1. Let's see how that would work. We're only getting 1s. Oh, this is because it's not preserved anywhere. Oh, it's a little bit more tricky than that. Where we have the first element of the tuple, we also need to extract the second part. And this cannot be 0. So this, I don't know what I was thinking. This is a return point. This is just the starting value of accumulator. So here, the next value of the accumulator will be second ACC plus 1. And this is second ACC. And we're getting 3s. Interesting. Well, the first thing that is definitely wrong is that we increment this name every time we encounter a row in the fold. This is incorrect. This is interesting. We will have to come up with a name for the new valent point, but it will have to depend on the same condition. So technically, it should go first. It's not very pretty, but let's see how the HLint suggests we fix that. Something like this. So now this is 2. Oh, because we scan row by row. So this is the... it's a little bit confusing because what we see in the markdown is transposed. So really a column is a row. Oh, of course that wouldn't work. Simply because a slice map produces a map, meaning there's only ever one copy of the new valent point. So once it gets a name assigned, it will always remain like that. Let's see if we can improve this. So this is it. This is where we check if the key of the map is equal to the value of the map, meaning if there's a valent point inserted. If not, the valent point should go first and the actual icon should go next. Okay. So we can forget about the slice map. Oops, sorry. Slice map we will leave alone. It was not the right place to put that sort of index in. Balance first slice, and balance seems a much more fitting choice. So in our case, value is an icon, so we technically should have a function that updates icons name. We already update dependents like this. So let's do update name. Sorry. I'm going to borrow some of this. update name. So what we want to return is the same sort of icon, just with an updated name. And I'm not really sure how the formatting for this should look like. So I'm just going to rely on H-lint. Sorry, H-indent. Do a wait. Oh, and while we're at it, because I checked out, it's no longer in memory, so I'll have to restart this somehow in the run script. Oops. Okay. Okay, this works for me. Let's run this. I'm not expecting anything spectacular to happen. This should still work. So we get zeros here. That's fine. Perfect. So just as an exercise, we are going to update name of the value. And let's give it name X. Hope this works. This is just a test. That's fine, we can live with that. No, the name does not get updated. On the other hand, why would it be? we returned the old name. Yes, it does get updated. So here, it feels like it would make sense to give those valent points unique names. So here we have the fold. So in the fold, we'll have to incorporate the new name. And let's start with 0. Sorry, let's start with 3. Just as a test. 3 is easy to spot. Oh, sorry. Inputs should stay intact. The accumulator should get the ID. So we only use the row like this here. So let's do FST row. Okay. And now sort of the second argument of a row is going to be ignored. Sorry, not the second argument. The second element of a tuple. Okay, what's the problem here? Oh, accumulator. And here, so many errors. Oh my goodness, what did I do? All right, so let's try to crack the accumulator once again. Let's just give it 3 to save some characters. And here should be... Oh, sorry. This row? Oh, maybe that was the problem with FSG. Okay. Okay. No, it's still not happy. Let's see this one. 261. Oh. Right. Oh, you can't do FSD on it, but... Now this is highly sophisticated code and elegant. First format, then rebuild. All right. So we don't need these after all. We'll remove this shortly, so I wouldn't worry. So now all the updated names should still be X. Let's just double check. there is still x. But now we can start thinking about incrementing the second element of the tuple that serves as the accumulator. So for now, let's always start with a 0. And here we increment. I don't mind this 0 for now. Here should be second accumulator. All right. This is fine. We don't have to worry about this for now. 0, 1, perfect. So we want to start with not a 0, but whatever we get here. Which will be an int. And we also ought to return it. But for now, let's not worry about it. Step by step. And let's start with 98, just for fun. So this one should be 98, this one should be 99. Oh no. Oh, of course. Okay. 98, 99, perfect. Now, we need to make sure that these new names persist across rows or the markdown columns. So what we need to do is we need to inform the caller of the new value. So now finally we can drop the FST. We can drop the blue bracket. We can decorate the input here with next available. Sorry. But also here, we're no longer interested in a tuple like that. Or we're not interested in a list like that. We're interested in a tuple. this will also sadly influence how we call this function. So for now, let's not worry too much about it. We're just going to politely ignore the second element of a tuple, with the plan to use it in a minute. So 98, 99, 98, 99, perfect. And now to keep continuity, let's do first slice. Oh, sorry. Okay. And because this is called recursively, we will also supplement it with the next available name for a valent point. And here, should this work? No, because this is still called the all the way here. And we should start probably with, let's start with 98, just for fun. So now we should have continuity. 98, 99, 100, 101. And obviously there is a syntax error here. Because we used the let keyword, we also need to use in keyword and indent everything a little bit more. Let's double check if we have that continuity. Yes, 98, 99, 100, 101. Perfect. Let's format. Let's see if this was intentional. It was intentional, okay. So we have it. So now there's no need to joke around anymore. We can use 1 as the first name, and also when we create valent points, when we update the name, we can get a little bit more creative. Let's see what HLint says now. Nothing. Format. Looks good. So now we have V1, V2, V3, V4, and it also serves another purpose, namely troubleshooting. It will be easier for us to determine the order in which the valent points were inserted, which is great. Okay, I think we're going to wrap it up for now. At this point, I'm just going to create a PR. Right, so this is pushed now. Let me take care of the PR. And in the meantime, I think that should be enough for today. In the next session, what I'm planning to do is to maybe start linking new valent points with their parents and with their dependents, giving them proper dependent names. But that is to be determined. For now, I would like to thank you very much for your attention and for sticking with me today, and I wish you a fantastic day ahead. Bye bye.